The next simple gas law that we'll look at is Charles's law, which states that volume is proportional to temperature.
A sample of gas has a volume of 2.80 liters at an unknown temperature. When the sample is submerged in ice water at T equals 0 degrees C, the volume decreases to 2.57 liters. Okay, so our T2 would be 0 degrees C, and our V2 would be 2.57 liters. So our V1 is equal to 2.80 liters, and what we need to calculate is T1, okay? So what is the initial temperature in Kelvin and in Celsius? Something you need to remember here is that for the simple gas laws, you have to convert Celsius to Kelvin. You have to use Kelvin units because Celsius has negative numbers, and so we want to make sure we're using that absolute temperature scale. We need to use the Kelvin scale. So we're solving for T1. So our equation is V1 over T1 equals V2 over T2. We solve for T1. T1 is equal to V1 over V2 times T2. So next we have to convert our temperature in Celsius to Kelvin. So to convert to Kelvin, we just add 273.15. So our temperature in Kelvin is equal to 0 degrees C plus 273.15. So we get 273.15 Kelvin. So now we can plug everything in. T1 is equal to V1 over V2 times T2. So that's equal to 2.80 liters divided by 2.57 liters times 273.15 Kelvin. And we get our T1 at 297.6 Kelvin, which makes sense because the volume decreases as the temperature decreases. So we started with a larger temperature and volume. Okay, so now we're going to convert that back to degrees C. So 297.6 minus 273.15, and we get 24 degrees C. Okay, so next we're going to work the for practice 6.3. Okay, a gas in a cylinder with a movable piston has an initial volume of 88.2 milliliters. If we heat the gas from 35 degrees C to 155 degrees C, what is its final volume? So we have V1 is equal to 88.2 milliliters, and I just went ahead and converted to liters to keep everything straight. So that's 0.0882 liters, and T1 is equal to 35 degrees C plus 273.15 is equal to 308.15 Kelvin, and T2 is equal to 155 degrees C plus 273.15 is equal to 428.15 Kelvin. Right. So next we're going to solve for V2. So our equation is V1 over T1 equals V2 over T2. And so V2 is equal to V1 over T2 times T1. Okay, so what we did was we multiply both sides by T2. So V2 is equal to 0.0882 liters, right, times 428.15 Kelvin divided by 308.15 Kelvin, and that gives us 0.123 liters. So that is equal to, if we multiply by 1,000, 123 milliliters.